Cool. So my name is Craig Hikus. I'm K0CAH, first licensed in 1974 as part of the Boy Scout program. I'm amateur extra right now. I'm an electrical engineer. I'm not a radio engineer, except as a hobby. I'm an integrated circuit design engineer, worked for HP, Intel, and currently AMD. So that's my background, and I'm going to talk about 3 stealth antennas that I use in my backyard, and they're all HF antennas. So next slide, yeah. First of all, I don't know how many people are familiar with Grid Tracker. Grid Tracker shows all the Maidenhead grids across the world, and a red dot is a confirmed contact through Logbook of the World or QRZ, and the yellow dots are unconfirmed. So the first time when I talk about these kind of antennas, people say, well, they don't really work. And I just show them this picture and I say, well, I can kind of cover Europe and the bottom part of South America and the US and Japan. And yeah, maybe I don't get Asia. But I think they work pretty well. So I've been using the stealth antennas for about 2 years. And I have over 9,600 confirmed contacts. And then I have my merit badges listed so you can see that I'm doing things. So let's start with, next slide, yeah, good. This is the backyard of my house, and all of my HF antennas are deployed. So as you can readily see, you can't readily see the antennas. So they're there, and you can't see them. So, but if I do this and give you some hints, I have a gutter, similar to Bob, up the side. I have a non-resonant piece of wire that runs across the top of the house and down, and I have a gutter. So those are my 3 HF antennas, and I'm going to talk about each one of the antennas in turn so you can know what I did with them. Let's see, yeah, okay. Why did I go with the stealth antenna? And the answer is pretty simple. HOA, we talked about HOA. Here's from my HOA, my little thing, not permitted, no exterior radio antenna, television. They spell antenna weird, but that's directly from my HOA agreement. They will let me have a satellite dish if they approve it. But let me go to the real reason why it's another version of HOA. I call it her override authority, and that's my wife. And there's house rules in the house. So the house rules are no visible wires, no visible poles, and no visible radio. So I have to keep everything hidden out of sight. So I'm a ham radio operator that's very stealthy. So let's talk about how we did that. First, I wanted to explain my setup. I'm in the garden shed. So you can see in the lower right the picture of the garden shed. I have a Flex Radio 6400, and that's here. I have a laser pointer, and it's got one button, and that's that green thing, and that's the oops. Now what did I do? Big one in the middle. Okay. It's got one button, that's the on-off button, and that's even remote controlled, so you don't even have to push the button. You operate the radio from the laptop, that's here, so we can operate the radio here if we want, or anywhere else. I use a remote antenna tuner, that's a ICOM AH4, and that's hidden down in the corner there. I have a direct connection to the antenna. I don't use an unun, so it's just a wire that goes out, and I have some pictures of that. I have a counterpoise, about 10 wires, and I have it hooked to the bunny fence to have a little engineered wire that goes around the inside of my fence to keep the bunnies out. Added it to the counterpoise. Some of the interesting stuff is shingles are an important part of my antenna system, so I want to document I have asphalt shingles. I don't think this works with metal roofs. Also, the siding of my house is an important structural element of my antenna. So I use hardy board cement siding that just happens to be on the house. I have solar panels, so I call those my mystery radiator. I have no idea what the solar panels do. I know with antennas everything affects everything, so they're doing something. And then I operate almost exclusively on FT8 and FT4, so I'm a digital guy. So that's where I'm at. And next slide. So let's start with the mag loop antenna. It's here. For some, you can see the big wide caps, spacing. So it's an air variable cap. You can get this thing off eBay today for $285 if you want. There's a retired guy in Florida that makes these and sells them. And so I bought one. The only mod I did is I added a little motor to it so I could tune it remotely. So what makes these antennas stealthy, so I usually keep it in my bushes. What makes them stealthy is the fact that I take it down and put it away when I'm not using it. So I take it out, set it up, and then I put it away when I'm not using it. So these are very high Q RLC circuits. So this is a capacitor, this is an inductor that has some resistance. So you know if you have a capacitor and inductor in parallel and you excite them at the right frequency, you get infinite Q. There's little R's, so it's not quite infinite. But you get some super high voltages. The modeling says I get about 15,000 volts at 100 watts across these two terminals. If you get time, you can come up and look at all the black arcing marks around here. I've had some issues with that. This coax, which I try to keep out of the way, is effectively ground potential to that 15,000 volts. It arcs right through the side of the coax, so there's a lot of tape around it, and I've tried to zip tie it out of the way. The rubber belt on the motor is critically important because there's 15,000 volts there and 0 volts there, so you better use a rubber belt. Some of the interesting things is I keep this in the house, and when I put it outside, the temperature changes, so the house is room temperature. Sometimes I put it out at 0 degrees, sometimes I put it out yesterday, it was 100 degrees, and the temperature changes. So they're tricky to tune, you have to get them just right, and then as they warm up, they drift, so I got to keep retuning and retuning until it gets to the right temperature. So I don't know what exactly is moving or expanding or shrinking when the temperature changes, but I have to retune as it reaches thermal equilibrium. See what else? It's a directional pattern. When I look at the contact reporting, so that grid tracker program I show you shows all the people receiving you, and I set this up and I'll get a whole bunch of contacts on this side and a whole bunch of contacts on that side, and kind of looks like a bow tie on the world map of who's hearing me. So that's directional that way. The nice thing is I can just turn it depending on where I want to work. Okay, so that's the loop. Go to the next one. This is the one I started with, the gutter. So I have a gutter. My ham shack is right behind this window, right in here. And the gutter runs up the side of the house and it runs over. And I have a thing that says stinger. I ran a wire. It's kind of hard to see because that little picture's in the way. But if that little picture wasn't there, you'd see the wire go up and it goes into my attic, and then I run another 40 feet or so out into the attic. So it's a gutter goes to here, a little wire that goes into the vent, and then around the attic, and it goes into the house that way. So this is a seriously bent up antenna. I was curious how to feed it, so I started with the automatic antenna tuner. I fed it directly, and I got a set of SWR, tuned SWRs. I fed it through a 4-to-1 and a 9-to-1, and the direct connect was actually the best SWR, so I just stayed direct connect. If you put it, this is a vector network analyzer, 1 megahertz to 30 megahertz, and the yellow line is the SWR. So I have a resonant point there, a somewhat resonant point there, another resonant point there, another resonant point there. 4 resonant points off an end-fed wire. I couldn't get EasyNet to make that happen, so I have no idea how to model this thing. So it's nobody would be proud of an antenna like that, except that it tunes up pretty well. It tunes from 160 to 6. You can see the SWRs that I get, and that's after the antenna tuner. And it's using the contract tracing in Grid Tracker. It seems fairly omnidirectional. I get tracking all around Colorado, north, south, east, west. I don't have to do anything. And I kind of explain that because I have a vertical element, which is horizontal, and then I have one with gain to east and west, and then when it runs into my antenna or into my attic and goes that way, I get north and south. Maybe, who knows? But I can resonate it and work. So let's go to the next one. Okay, so I had set myself up for direct connect, and I wanted to run. I wanted to make this easy and remote, and I didn't want to have to to change anything, so I wanted to stay direct connect. And so I learned all about end-fed half waves, and at the end of a half wave, you have a very high impedance. My tuner is a good tuner, but it can't tune the infinite impedance in theory at the end of a half wave. So I needed to find a length of wire that wasn't resonant at a half wavelength on any of the bands I wanted to work on. So I wanted to work on these bands, and I needed to find a length that was not near a half wave resonance. These antennas, if you read a little about them, are not called random. This is not a random length. This is a carefully calculated length. And because it's fed directly with an unknown, I need to find a length that is not close to a half wave length at any of the frequencies I care about. And I wrote a little program that's down here, and I found a magic number that worked for me of 70. And so I made took a 70-foot piece of wire. It also had some near it that were not, these numbers mean something in my program, but the zeros were good, so I picked 70 feet. And so I ran it. It comes up the side of the gutter, and then you can kind of see it going across the mystery reflectors, the solar panels, and then to an anchor point here, and then I just threw the end of it off with a weighted pipe on the end, and it just lays on the roof. So technically, you can see a little bit of it as it flies across above the gazebo. You kind of have to look through the gazebo, but my wife's okay with it, so everything's good. And you can see it tunes up pretty well, too. And that's, again, after the tuner. So those are the three antennas. I wanted to talk about the performance of each of them. I'm a data guy, so I log everything that's happening. So I have this is the non-resonant length, 70-foot piece of wire, the gutter and the loop. These are the bands down this side. These are the number of confirmed contacts I've had on each of the bands crossing each of the antennas. So you can see here, at 10 meters, I've had 12 on 70 on the wire and 41 on the gutter, and the loop doesn't tune there. You can see the loop, it covers 17 through 40, and you see the number of contacts I've had on the loop for each of those. The gutter is my workhorse. You can see that I've got most of my contacts off the gutter. But I'm also interested in distances. How far am I getting out? Part of the hobby for me is to see how far I can get out. That's the exciting thing, not necessarily local, but how far do I get out? So I wrote a little program that takes the ADIF file that you can download from QRZ or Logbook of the World, and it converts the ADIF into Excel, and then you can pivot the data. Also, that program calculates all the maidenhead distances and launch angles and other things. So I have a distance for every contact, and then I said I want to just take the average distance of in miles of each of the antennas operating on each of the frequencies. So the 10 meter on the non-resonant wire, my average contact distance is 3,000 miles, so that works pretty well. So you can, but that's only over 12 contacts, so that's part of it. What you can see is a clear signal. The non-resonant wire outperforms fairly significantly the gutter. So you can see in almost every case there's maybe a 30 to 50% uplift for using the wire over the gutter. So I thought that was kind of interesting. And then you can see the loop is a solid performer. In fact, the loop is my best performer at 40 meters. So that's just some data on how well these antennas perform. Go to the next slide. I wanted to give some details about how I hooked this all up. There were some questions. So I have the flex radio over here. I have a piece of coax that runs about 10 feet over to the tuner. I have a bunch of ferrite beads on the coax, and that's to kill the common mode that might show up on the coax. And there is common mode because if I operate a while, these things get hot, so they're actually killing things. It's killing common mode current. I have I called these intentionally short wires. The antenna system actually starts on the gutter and the wire, comes through all the way through into, and it contains components in the tuner as all part of the antenna system. It's only 50 ohms when it finally gets to there. So you have really unpredictable currents on these short wires, and you want to keep the wires short. So the tuner goes into, I'm a safety guy, so I have a normally closed relay. I couldn't draw it that way because look stupid, so I drew it normally open, but it's really a normally closed. So when I kill the power to the radio, it kills, it shorts out this wire, and any lightning that could potentially get through, or strong RF fields won't take out anything in the house. The gutter comes in, goes through the lightning arrestor, a short wire into the relay, and then into the tuner and into the radio. The polyphaser, the lightning arrestor, is mounted on an 8-foot ground rod. I have about 10 counterpoises that go out at different lengths, including the one that goes out and grabs the fence. So I just threw that in there. I was worried about counterpoise links, and counterpoise are kind of the opposite of the driven element, and those two should be matched as a pair. Well, nothing in my driven element was matched. My antennas are completely random to anything we think about in terms of resonant systems. So I decided to make my wire links random too. Why bother trying to match them? So I just have a bunch of different links, about 10 of them, and I didn't try to match wavelengths. And then let the tuner has now the ability to pick the one that resonates the best with however it's resonating the rest of the system. So that's kind of the connection. If you do one more slide. So the flex radio's here, the tuner's here. There's the grounding relay's here. On the back side of that wall is the ground rod and the lightning arrestor. It's mounted on an 8-foot rod. You can kind of see a terminal strip here, which has all the wires that go out for the counterpoise, and you can see the direct connect over to the gutter. And if you look really hard, you can't really see, but there's an ability for me to switch between the gutter and the random wire. All right, go to the next slide. Wanted to show a little about tuning. How do you tune remote radios? And so I have two tuners, really. I have the one that tunes the loop, and I have the one that tunes the wire in the gutter. So this is the ICOM AH4 with the lid popped open, so it's just a commercial tuner. Here's all the coils and capacitors that it can switch in. On a remote control radio, I just put the radio into, I select tune there and hit tune, and it sends a little power out and tunes to whatever SWR it finds. And then I go into normal mode, and here you can see I'm driving 100 watts. Here's the power, and the SWR is staying the same. So that's how you operate the tuner from the radio, and the radio is this anywhere in the world. It's my laptop. It's really in the shack, but I'm talking to it anywhere in the world over the internet to talk to it. The loop controller is a little bit different. It's a Raspberry Pi. Remember, it has to be remotely controlled too. So it's a Raspberry Pi. It's got a motor controller hat on it. That's a board you put on top of the Raspberry Pi. This is a 12-volt junk box adapter I had. That's a 12 to 5-volt converter for the Pi. And then the Pi just hooks into the internet, and I have a little interface panel, and I can go forward and I can go back, and I can go fast and I can go slow. I can nudge forward and nudge back. So I wrote a little interface so I can drive the capacitor, rotate the capacitor remotely with that. So those are my tuners. Question came up about RFI in the house. My antennas run up the corner of the house, my wire and my gutter, and so you can use the RFI exposure calculator. This is from ARRL, and you can type in what you think your gain is. I said I had no gain, just 0. And at 10 meters, I need to stay 3 feet away from the gutter, and I need to stay a foot away from the gutter at 40 meters. It gets worse the higher you go up. So the corner of the house upstairs of the garden shed has living space. So we put a large plant in the corner of the dining room to keep people 3 feet away from that RF source in the corner of the room. For RFI, the biggest problem I had in the house was analog computer speakers that are amplified that have long wires on the inputs. And when you broadcast, you pretty much hear yourself in the computer speakers. Pretty easily fixed. You put a bunch of ferrites on those wire inputs to the amplified computer speakers, and that takes the RFI apart. had another RFI problem with my flex radio. So I have a piece of Cat 6 about 100 feet long that runs from my router over to that flex radio, and it's grounded at the radio. So long wires grounded at the radio look like counterpoises. The RF doesn't know it's a LAN cable, it sees it as a counterpoise. So I had a problem that every time I cranked up the power, I lost the network because I was probably generating some nice AC voltages on the LAN cable. So I replaced the LAN cable with a piece of optical fiber and used Ethernet to fiber converters on each end, and that absolutely completely solved the problem. So I have, my radio works on the home network and it's out there. Another problem people have with RFI, but I had none. I was glad about this because I have a lot of GFCIs and AFCIs in the house. My AFCIs and GFCIs don't trip, so that's a good piece of news. And then I have a ghost story about the gas fireplace. So after I installed the wire that went across the top of the house and down, the non-resident wire, it actually ran over where the gas fireplace was. Gas fireplace is one where you flip the switch on the wall and it comes on, and you flip the switch down and it goes off. So there's a little gas valve in there and a little controller. So when you flip the switch on, this little controller says, all right, let's open the gas valve and let's run us a little sparker and see if I get heat, and if I don't get heat, turn it back off. So it's a little computer state machine doing its thing. And my wife came in one day and she said, I was in a different room, and she said, something's wrong with the fireplace. And I said, what's wrong? And she goes, and for those that know FT8, it's on for 15 seconds, on for 15 seconds. She goes, the fireplace comes on like for a few seconds, and then it goes off for like a few seconds, and then it comes on for like a few seconds, and then it goes off for a few seconds. And she goes, I think we have a ghost. I go, are you, I didn't know what it was, but then I'm like, oh yeah, I know what it is. It perfectly matches the timing of FT8 transmissions. So the ghost was nothing harder than a few ferrite beads on the wiring from the wall switch to the controller. I put the ferrite beads on that, and that completely killed the gas fireplace issue. And I think I have one more. Summary. So stealth antennas, do they work? Yes. Are they stealthy? Yes. Can you have fun with them? Yes. Are they compromised antennas? Absolutely. Do I still want a tri-band Yagi on a 60-foot tower? Yes. Is my wife happy? Yes. Anyway, that's my story. So, stealth antennas. Any questions? Oh, do you have a mic for the questions? Oh, okay. No, doesn't work. Okay. I can repeat the question.
I saw you had a bash terminal open. Were you using Linux at all?
Yeah, I use a lot of Linux, yes.
Okay, that's all.
Okay, yeah, Raspberry Pi is a Linux-based computer.
Right.
Other questions? Yes.
Actually, it's not really a question, it's a comment. You're using metallic guttering. You have to make sure that those sections are all very carefully connected, very low impedance connections, definitely non-ohmic problems. Otherwise, you get all kinds of harmonics and the thing gets erratic in tuning. Now, for the people who happen to have plastic downspouts and plastic, the sneaky way to do it is to just run a wire up and around.
Inside the gutter.
And then you don't have to worry about that.
Yeah, so I was worried about that, and fortunately the house has what they call continuous gutter on it, where they make it in the street, so the vertical element is all one piece, the horizontal element is all one piece, and it has it had 2 sheet metal screws in. I put a couple more sheet metal screws in where it connected, and then the little stinger that goes off the end, I scraped all the paint off. I used wire lug and silicone, and hopefully that doesn't corrode. So, but I was worried about that. Anything else?
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.